Hello, everyone, and welcome back to the 2023 Hack Summit. We're joined here by John Shutt, the co-founder of the Across Protocol, which was incubated by the UMA project. And John, it's a pleasure to have you here today. Thank you for joining us.
Yeah, thanks for having me. I've been watching a lot of the talks and panels so far. It's been really interesting all day.
Thanks. I've been learning a lot too. We're very grateful to have speakers like you helping the charity. So thank you for being here. So I think to set the stage, there's a number of projects that UMA has created over the years. Can you give us a little bit of background about what is UMA and what are the major initiatives that are going on within UMA? And then we can get into Across after that.
Yeah, so UMA is an optimistic oracle. It can deliver any kind of verifiable data to your smart contracts on EVM chains. So the number of things that we do is actually pretty extensive. We started out with a real focus on derivatives and synthetic tokens and that kind of thing, a real DeFi heavy focus. But over time, we learned that because the Oracle is so flexible, it can handle a lot of natural language questions. So we're doing prediction markets and insurance. You mentioned Sherlock and some of the other talks. They use us as a backstop after their committee. Cozy's another insurance protocol using us. And then the Across Bridge is something we realized we could build to solve the fast withdrawal problem for L2s before the L2s actually launched, because taking 7 days to move from L2 to L1 was going to be a big issue. And we pushed it even further and realized that we could actually layer a relayer system on top of that to make bridging almost instant, and just use UMA's Oracle's flexibility to enforce that all the fees and everything else were done correctly. So that's all been really cool. There's some other initiatives that we're doing right now too around governance. A lot of DAOs have a problem where you have voting on snapshot where the DAO's will is expressed, and then you hope that a multi-sig actually does the thing that you voted on. And sometimes they don't. And even if they do, it's not really pleasant to be a multi-sig signer. It's really annoying and inefficient and potentially legally hazardous. So we built a tool called OSNAP, which is for defining the natural language, just plain human readable rules of your DAO. The basic ones are just if it passed on snapshot with a minimum voting period and quorum, it's valid. If not, it's not. You can add additional rules to that too, and just see where DAOs can go once they're not limited to things like multi-sigs and on-chain voting that are just easy to write into code, but maybe not the most natural way to organize human beings. So we do a lot. Our challenge is keeping it like focused because there's so much you can do. And luckily, we've got a lot of inbound now of projects that have their own ideas, and we're just helping them spin it up. So I spend a lot of time working on that too, just the integration side.
That's fantastic. And John, just so that the audience is all on the same page, what is an Oracle? What does an Oracle do?
So smart contracts have a problem where they don't know anything about the outside world. They only know what's within the context of their own contract, or potentially like other contracts that they can call on chain. If you want to deliver any kind of external data to a smart contract, you want to have some reason to trust that data. You can't just say like, oh, John said the data, so it's probably fine. I mean, you can, and that was kind of how oracles started out, like quasi-oracles. But you want to have a decentralized and really trustworthy system for getting that kind of data, verifying it, making sure that it's correct. And UMA's built that. So our model of it allows anybody to propose the data and put some money behind it that they're going to lose if they're wrong. And then anybody can dispute them. And that dispute gets escalated to UMA's token holders to do a shelling point process, a secret commit, then public reveal scheme to arrive at the answer. And because it's human mediated at the end to resolve disputes, it's really, really flexible. And there's recourse if some data turned out to be wrong for whatever reason. So that's pretty much it. I think that a lot of the potential for what crypto can do is reliant on oracles. We can obviously see that with DeFi, but just going beyond DeFi and going beyond like, oh, here's the price of ETH or BTC or something. Most of the interesting things that could really affect society in a positive way has to be able to like tell what's going on out there. It can't just be like insular, here's what the contract says, that's all we need to know. You can do a lot with that, but it's ultimately very limited.
And in your experience, is the primary use case of oracles price feeds and getting financial data off chain to be on chain, or is there a product market fit for broader use cases of oracles these days?
I think there's definitely a product market fit for broader use cases. And I say that partly because that's our product market fit at the moment. We don't do a lot of price feed type stuff. I think people think that oracles are mainly about price feeds because obviously DeFi has been very successful. And I think Chainlink is the most well-known oracle system, and that just sort of works that way. That you have this data feed, it confirms some data, it pushes it on chain. But if you're able to have this kind of proposal and then dispute process, it really opens up the design space of what kind of data you're talking about. So for instance, you could say, here's a bunch of transactions that follow the rules of the DAO. Here are the rules of the DAO that a human can read and understand. You're not going to be able to get a data feed that tells you whether or not those transactions follow the rules. It's just, not possible. Or something like smart contract insurance, which we do that plus other types of insurance. If you knew in advance how a smart contract was going to get hacked, and you could set up a data feed that you subscribe to that says like, yes, it's hacked or not, I mean, you could probably prevent the hack in the first place. You really kind of need to be able to look at it and determine what the truth is. So, insurance, prediction markets, and then bridging itself, the across bridge, it's got a really sophisticated set of validations. It's much more bot driven than prediction markets or insurance. Like bots can go in what's going on, all of these different chains where across is active, and they can calculate and make sure that all the fees are done correctly down to X number of decimal places. But that's really, really hard to do too if you don't have that flexible Oracle infrastructure.
Makes sense. So tell us a little bit about the problems that you're solving with Across, and how does Across work to solve those problems?
So Across is really focused on cross-chain bridging of assets and value. Initially, it was focused on that L2 to L1 fast withdrawal problem. The V2 of Across expanded it, so you've got L2 to L2. A couple of features that I think are really important is we only use the canonical tokens, so we can avoid a lot of the areas where bridges can get into trouble if you have a wrapped token or some kind of representation of a token. But if the bridge gets hacked, your entire ecosystem could go down. Across isn't exposed to that because it's only the tokens that came over the canonical bridge of whatever chain you're on. So Arbitrum's bridge or Optimism's bridge, Polygon's bridge, where if like the token that came over that bridge went down, it's because the entire chain went down, and you've got larger problems there. Across has concentrated liquidity. So most of the liquidity stays on L1, Ethereum L1, which is the, I would say the safest chain. But you get a lot of capital efficiency there. Like as you're moving tokens back and forth between all these different chains, generally things net out, and you only actually need to bridge from L1 to some other chain, or from that chain over like a slow 7-day bridge back to L1 on rare occasions. And looking towards the future, we're expanding to more composable bridging, where you can send some funds to a chain, and you can also send a message saying, here's what I want to do with it. So if you were to do something like, you want to buy some token on Arbitrum, but all of your funds are on Optimism, you could say, buy this token on Arbitrum, and your funds can be sent from Optimism and then trigger the swap as necessary with whatever protocols you're using, which I think is really cool with account abstraction in particular. Because Across's infrastructure, is theoretically as fast as it's possible to be. You have a third-party relayer on the other side that actually delivers the money and then comes back and requests a refund from the Across protocol, which is disputable with UMA. So the relayer is like waiting a couple of hours to get their money back. You as a bridge user, you put your money in, you get your money out, usually within like 3 to 5 minutes. If you're moving like a huge volume and relayers need to put some cash together on the receiving chain to fully fill that, it might take a little bit longer, but generally, it's as fast as it's possible for a bridge to be. And that's important for account abstraction because with that, you could actually take finality risk as a sender. If the user has something in a wallet that you're controlling because you have some permissions to send funds around on their behalf, you're the one sending the funds. And then you're also, at the other end, potentially relaying from some other accounts that you control. And so if there's a reorg on the sending chain, you don't necessarily have to worry about it because you know that you're able to send the funds, again, anyway. I'm getting probably way too into the detail of it, but I'm just really excited about it. I think in the future,
it's fine to me. Actually, I think there's a lot here for the audience to learn. So let's just double click on some of this stuff. So first of all, let's get an understanding of the definition of the term optimistic, and how does optimistic approaches work within your protocol. Can you go over that real quick with us?
Yeah, so basically an optimistic mechanism for verifying something assumes that an initial proposal or assertion is correct unless it's disputed and proven to be incorrect. And that's good in a lot of ways. One is it's just a lot cheaper. If you compare it to a data feed type architecture where you have to have 21 nodes that are all reaching consensus before they tell you the price of Bitcoin, that's going to cost a lot more to maintain than just one honest person gives you the price of Bitcoin. And it's probably just as good if there's recourse where you can dispute that person. And that you only need one honest actor to actually step in and propose and dispute. People might be more familiar with optimistic rollups. It's kind of a similar concept, but it's expanded to pretty much any data that's verifiable. So that could be some off-chain information about like, who won the basketball game, or like, was Trump indicted? Those are some markets that we're settling right now. Or it could be like, was the smart contract hacked? Like Euler was hacked, and so there were some insurance payouts that were triggered through UMA's system. But it could be these kind of complex calculations like what Across is doing, where theoretically you could actually do some of this stuff through technical validation, write a ton of code that would do it, maybe. But it actually wouldn't be as quick, and it definitely wouldn't be as cheap as just doing the optimistic thing, where you can just look around and tell what the correct answer is. All you really want is the output of like the correct answer. You don't need to do all those calculations on chain or like pass a bunch of messages between chains and then calculate it somewhere. Just calculate it off chain and say, here's the number, or here's the yes or no answer.
Makes sense. And is the optimistic approach, is the goal of it to basically introduce speed of transactions? And do you have to wait a while before knowing if your transaction succeeded or not, given that you're making some assumptions up front?
The relayer has to wait, but the bridge user actually doesn't. So for a relayer, you're basically giving, let's say that the user is bridging 10 ETH from Optimism to Arbitrum. You're going to give them a little bit less than 10 ETH on Arbitrum after calculating what your relayer fee is plus what the LP fee is for the concentrated liquidity providers. And then you just say like, hey, I did all the fees correctly. Please refund me on, let's say, Polygon, because you can request your refund anywhere. And the optimistic approach allows you to do something complicated like that, and then bundle up all of the relayer refunds and verify them all at once. And so you can say, here's a proposal, here's 1,000, 2,000 relayer refunds that were all calculated correctly. Please execute on all the various chains where it's relevant. So the relayers are waiting, but the bridge users have actually gotten their money already, and they're in and out of the system.
That's fantastic. And you mentioned earlier about that you don't use wrapped assets, you use canonical assets. So maybe just so that the audience is all on the same page, can you tell us the difference between those two, and what are the risks of having wrapped assets?
So a wrapped asset, generally speaking, you would deposit, let's say, WETH on Ethereum into some designated smart contract, and then a bridge would mint some token on some other chain that is basically synthetic WETH. It's representing a claim on the WETH that's on Ethereum. And as long as the bridge doesn't get hacked or has some vulnerability or something like that, you can trade it around as though it's regular WETH. But sometimes bridges get hacked, and those are the most high-profile targets because they have so much money locked up. What Across does is we don't do any wraps like mint and burn or like mint and whatever mechanisms. We just use the canonical bridge for each chain. And right now we're only limited to chains that are directly connected to Ethereum. So chains that have that canonical bridge, like rollups, like Optimism and Arbitrum. Polygon has a canonical asset bridge. Looking a little bit in the future, actually, though, we are adding some ZK messaging that'll let us expand to Avalanche and to BNB. But there's like more details to work out on the pricing to ensure that you have enough liquidity on those chains, and that'll kind of put us into a new territory. But it eliminates that risk of like, oh, the bridge was hacked, and so this $500 million of wrapped assets are actually backed by nothing now. We're not backing them. You're just getting the canonical thing that came over the chain's native bridge.
Yeah, and I assume there's less contagion risk within various ecosystems if you don't have wrapped assets as well, right?
Right, exactly. I mean, we just have the canonical tokens. They're sitting mostly in the hub pool on Ethereum L1. That's like the shared, generalized liquidity. And then spoke pools that have like a little bit of cash on each chain, enough to satisfy the withdrawals that might be happening at any time. And then they kind of get replenished back and forth through netting, where if you're going from one chain to another and then that chain back to that chain, you're pretty much even, which keeps it really efficient. So you're not worried about that as a bridge user. You're not worried about getting an IOU that can't be paid out. You're getting the actual thing.
And are there use cases for Across other than assets? Are there other use cases of the protocol?
I think so. I think as you get into more composable bridging, where you can attach a message along with assets that you're bridging, a lot of cross-chain interactions become possible. And I kind of hinted at how excited I am about the potential with account abstraction in particular, that you might just have like, here's a global wallet. It's all the stuff that I own everywhere. and I'm just going to like give instructions on like how these things should be executed in a way that are maybe more human understandable. Across being able to send messages between chains in the next version is really going to open up the cross-chain design space. And it's not going to expose you to just unlimited risk either. Like the only funds that are at risk are the funds that you're sending to whatever other chain. So if you're like, here's 1 ETH, swap it for USDC, you're not going to somehow lose like 100 ETH because of like some, you know, misconfiguration of your transaction or some issue with an arbitrary message bridge. It's really only the funds that you're sending plus whatever the message was that was attached, which I think is a good safety thing. But I think a lot of this too, it's going to be under the hood. I think a lot of this becomes invisible infrastructure ultimately. And I think that we've really seen that too with our success with aggregators. Across just kills it in aggregators. Like we're first a lot of the time, just really fast, really cheap, and you know, ranked on security as well. So that's a good place to be if you're just legitimately faster and cheaper and just make it easier. People will build consumer-facing products on top of you, and the users interact with that, and they're not really thinking about these bridge mechanics. I think the fact that people have to think so much about bridge mechanics and like, is this bridge secure or not, is because we're so early and because bridges are getting hacked left and right. So if you can build something that's just really stable, it's not, you know, it's not going anywhere, nothing bad is happening. You're not thinking about that infrastructure. You're not thinking like, what if this literal physical bridge collapses underneath me as you're driving across it, which you unfortunately have to do with a lot of other crypto bridges at the moment.
And do you think that bridge aggregators are eventually going to be the point of contact that most dApps have with bridges, or do you think that projects will go directly to bridges in the future?
Yeah, I'm not really sure. I mean, I think like if projects start going directly to bridges in the future, it's because they sort of have their own in-house sense of like aggregation. Because presumably they would want to give the best possible service to their users. So they're going to be ranking bridges internally and deciding where to route it. So if they're not using a third-party aggregator, like I think that you should probably figure out how to do that yourself then. But I think the aggregators are really strong. You know, I think they keep adding new features. I think they're definitely like carving out a space within the ecosystem. But I think even with like the aggregators, I don't think users will be necessarily directly interacting with the aggregators. They'll interact with some application that then interacts with aggregators that then interacts with bridges.
That's right. Yeah, we noticed that like Uniswap for their governance module, they had a request for proposals for bridges to pitch them, and they kind of ranked the bridges and they evaluated them, but they have the resources to do that. They have the engineering resources to compare the bridges, but I would assume that most dApps don't have that. And so there seems to be like kind of a hybrid market here where the apps that have really strong engineering talent and have the resources, and maybe they have billions of dollars at stake and they have the time to evaluate each bridge. Maybe they'll hand pick their bridge, right? And then maybe the less mission critical apps may just trust a bridge aggregator to do it. But I think it's a tough decision right now. I think because we're in the point today where so many bridges have been hacked that you don't really know who to trust right now. So can you even trust an aggregator? Like that's an open question, I think, right now.
Yeah, I think that's fair. And I think also part of that, I wasn't really thinking about it in the context of bridging between chains that don't have some native way of like canonically bridging tokens between them. Because the across context is all about being a liquidity network for chains that are already connected anyway. It's just they're connected in a way that's kind of slow. Like you might have to wait 7 days to go over the native bridge, which isn't reasonable. But if you're going to like some brand new chain that has like no connection to anything, you kind of have to go through that process of like, why should I trust the IOU token on the receiving chain? And there's a lot of different approaches to that. And for that, just picking one, I guess I can see why that would make sense. I can also understand the approach that some projects have of being natively multi-chain, where if maker is like, oh, like we're going to mint DAI over here and we control those contracts and we're not trusting a bridge. We are a bridge. We're a natively multi-chain token. We'll do mint and burning ourselves, which is also an interesting approach.
I have time for two last questions. One from the audience here. What do you think of the future is? Is it optimistic rollups or zero knowledge rollups? Do you have an opinion on that?
I think it's both. I don't think that these technologies contradict each other. And even within across, like we're embedding some like zero knowledge stuff into the next version to be able to like verify messages that are sent from Ethereum to L1 to Avalanche and BNB and like other chains that don't have a native way to communicate with them and do some technical verification there. I think there's also like, you could use an optimistic mechanism to verify a zero knowledge proof. which is a point that some people have made, and like I make sometimes too. Like that, it's the same way that like Across's calculations can be done much more cheaply off chain. You can do a zero knowledge related calculation off chain, just deliver the output, and then fall back to the expensive on chain calculation if it's ever disputed. But that can be really botched, and there's benefits to it. And I don't think there needs to be like a winner. I think most of what you would build across both.
I love that comment, especially given how computationally expensive zero knowledge proofs can be. That seems like a very relevant approach to do that hybrid off-chain approach. Last question was just from me. So one of the things that I noticed about UMA is that you guys are trustless and that there's no real central point of failure with the UMA architecture. How important has that been for you guys in terms of your vision for the future? And do you think that centralized solutions can be trusted? And are you seeing incidents occurring there? And what's your view on the practical reality of how important it is to be trustless? Any thoughts on that?
I mean, I just think that trustlessness is a core feature of most of the things that are interesting to build in crypto. So if it doesn't have this aspect where it would benefit from being a trustless system, it might make sense to do it with like a centralized entity. Like, I don't think like every pizza shop should be centralized or something. Like, I think it's fine to trust like the person running the pizza shop to just like make pizza, and that's like a normal just business that you're doing. But if you're building like a lot of the crypto stuff, if it's not decentralized, its purpose is often unclear, and it's vulnerable to a lot of types of attacks that you're simply not exposed to in a fully decentralized system. So I think you want to be focused on that from the get-go. And it was interesting with Across. I mean, we're very focused on it there too. We kind of thought that maybe we would like build this V1 of the protocol, release it to the world, and then some other dev team would start working on it. And the only reason it kept being us is we just kept having ideas. We were moving faster than anybody else could possibly do. So it's like, you know what, we'll ask the community's permission now to continue building this thing like we've built.
And in my experience, open source, that is very common. A lot of folks who create an open source project, they have this vision that the community will take all the burden off of them. And in reality, you have to do the heavy lifting for the first few years. And then eventually the community kind of takes over. So that's not surprising. And by the way, for what's worth, I agree with you. And I think the FTX crash has kind of taught a lot of folks that you really can't trust other people. And I think trustlessness has a very strong tailwind thanks to the FTX crash. So I do believe in the future being trustless. So John, thank you very much for being here today. It was great having you. We learned a lot. And appreciate all your insights today. It was very thoughtful.
Yeah, thanks for having me on. I'll keep listening to all the panels and talks.
Great. We're going to be right back, by the way, with an amazing speaker. It's going to be Eli Ben-Sasson, the co-founder of Starkware, who's pioneered both Zcash as well as a new kind of revolution called Starks. And we're going to be learning all about